Hello everyone and welcome back to the channel. Today we are taking a slight detour from our linear algebra series to focus on something more crucial for the FYBCom students out there, commercial statistics. With your exams around the corner, we are going to tackle some important topics by solving some actual questions from the April 2023 question paper. In this video, we will be covering bivariate linear correlation and regression and time series and index number. To make it easier for you to jump to the sections you need, I have added timestamps in the description below. You will also see cards popping up during the video linking to related topics. Let's get started and boost your exam preparation. On the screen what you see is the April 2023 question paper of FYBCom titled Mathematical and Statistical Techniques 2. Question number 3 is from the unit Bivariate Linear Correlation and Regression, while question number 4 is based on the topic time series and index number. So what we are going to do is we are going to solve all the numerical problems listed here, which means we'll be solving B, C, D and E from question number 3, while we'll be solving B, C, D and E from question number 4. Let's get started. The question is, compute the correlation coefficient for the following data, and we have a bivariate data for values of x and y. Recall that the formula to calculate the correlation coefficient is given by small r is equal to sigma xy upon n minus x bar y bar over square root of sigma x square over n minus x bar square multiplied by square root of sigma y square over n minus y bar square. So we are going to modify our table and we'll be rewriting this as x, y, xy, x square, y square. So we have in x 3, 2, 3, 4, 1, 2. In y we have 4, 4, 5, 3, 8 and 6. Now for x, y, we are going to multiply x with y. So the first entry is going to be 3 times 4, 12. Next would be 8. 3 times 5 is 15. Then 12, 8 and 12. Next we have x squared. So for that we need to square the entries in x. So the first entry is going to be square of 3. That will be 9. Followed by 4, 9, 16, 1 and 4. And lastly we have square of y, so that will be 16, 16, 25, 9, 64 and 36. Next we are going to total column of x. So that is going to be 3 plus 2 plus 3 plus 4 plus 1 plus 2, that's 15. The total of y will be 4 plus 4 plus 5 plus 3 plus 8 plus 6 and that's 30. Total of xy, so that's 12 plus 8 plus 15, 12, 8 and 12. That's 67. The total of x squared will be 9, 4, 9, 16, 1, 4. That's 43. And total of y squared is 16, 16, 25, 9, 64 and 36, which is 166. Once we are done with this, we will start approaching the formula which we have specified right here. So as you can see, we'll be needing x bar and y bar. So for the next step, we are going to evaluate x bar. And as you know that x bar is given as sigma x over n. Sigma x we have got as 15 over n, which is the number of bivariate observations, which in this case is 1, 2, 3, 4, 5, 6. So n is 6. So this is going to be 15 over 6 and that gives us 2.5. Then next we evaluate y bar. So y bar is going to be sigma y over n and that is going to be 30 over 6, which is going to be 5. So as from the left here we have R is equal to sigma xy. So sigma xy is the total of xy, which is 67. So we get here 67 over 6 minus x bar we have got as 2.5 and y bar we have got as 5. So this is going to be 2.5 times 5. Here it is y bar. And then this is divided by, so we have square root of x squared, sigma x squared, and that is going to be the total over here, which is 43. So we have 43 over 6 minus x bar square, that's 2.5 square of it, times sigma y square, and that is 166 over n, that is 6, minus y bar square, which is 5 square. We have got 67 over 6 in the numerator, and that's 11.166. We are going to round off every number up to 2 decimal places. So this is going to be 11.17 minus 2.5 times 5 is going to be 12.5 over, in the first square root in the denominator we have 43 divided by 6, and that's 7.17 after rounding off, minus 2.5 square is 6.25. This goes inside the square root. And then next we have 166 over 6. That's 27.67 after rounding off, minus 25. Completing the subtraction in the denominator is going to give us negative 1.33. And in the denominator we are going to have 7.17 minus 6.25, and that is 0.92, while the second square root is going to be 2.67. Let's calculate the square root of these numbers. So square root of 0.92 is 0.96 after rounding, and square root of 2.67 is 1.63. So we have got in the denominator 0.96 times 1.63, which is 1.57 after rounding off, and thus we are left out with the final answer, which is going to be negative 0.85, and that is the coefficient of correlation which we are looking out in first question. Let's get on to the second problem. So we have the question, find the rank correlation for the following, and we have a bivariate data. The first row gives us marks 1, which is 30, 40, 50, 10, 40 and 70, and you can see that the number 40 is repeated twice. Likewise in row 2 we have marks 2, which is 75, 32, 45, 15, 20 and 45. So over here 45 is repeated twice. So this is the problem on rank correlation for repeated ranks. So first we are going to have marks 1 followed by marks 2. Then we are going to have columns for rank 1 which relates with marks 1, and column for rank 2 which relates with marks 2. Then we have D, and lastly we have D squared. So in marks 1 we have 30, 40, 50, 10, 40 and 70, while in marks 2 we are having 75, 32, 45, 15, 20 and 45. Now for little rough work, what we are going to do is we are going to rearrange marks 1 in descending order. So the highest marks is going to come first. So we have got 70, then next we have is 50, then we have got twice 40, then a 30 and a 10. Now ranking, we are going to give 70 as 1, 50 as 2. These we are going to just for time being write it as 3 and 4, and then we have 5 and 6. Now observe for entries 40, we have got two different ranks 3 and 4. So we are going to assign both of these 40 the rank which is average of 3 and 4, and the average of 3 and 4 is 3.5. So 70 is going to get rank 1, 50 will get rank 2, while both the 40s will get rank 3.5, 30 gets the rank 5, and 10 gets the rank 6. And likewise for marks 2, we have got the highest number to be 75, followed by two 45s, then next is 32, 20, and 15. Again, this is going to be rank 1. These two, 2, 3, then we have got a 4, a 5, and a 6. Now again, since both of these are repeated ranks, so we will be giving them the average rank, and the average of 2 and 3 is 2.5. So we have got 75 getting rank 1, both 45 is getting rank 2.5, 32 getting 4, 20 getting 5, and 15 getting 6. Let us put that in our table. So 70 is rank 1, 50 is rank 2, then 40s have rank 3.5. So we'll be having 3.5 here and 3.5 here. Then 30 has rank 5 and 10 rank 6. In marks 2, 75 has rank 1, then both the 45s have rank 2.5. 32 has rank 4, 20 has rank 5, and 15 has rank 6. Now D is the difference between R1 and R2. That means we got to do 5 minus 4, which gives us 5. Then 3.5 minus 4, which gives us 0.5. Again 0.5 with a negative sign. Then we have a 0, we have a negative 1.5, and we have a negative 1.5. Now D square is going to be square of these numbers. So square of 4 is 16. Square of 0.5 is going to be 0.25 with a positive sign. Same over here. Square of 0 is 0. And this is going to be 2.25 and 2.25. Now we got to total only D squared. So let us total D squared. So that is 16 plus 0.25 plus 0.25 plus 2.25 plus 2.25. And that's coming to us as 21. Now for the next part, we are going to write down the total correction factor. In marks 1, we had 40 to be repeated twice. So the correction factor from here is 0.5. And in marks 2, we had 45 to be repeated twice. So again, we have a correction factor of 0.5 from here. So the total correction factor is sum of all these correction factors, which is 1. Once we are done with this, we are ready to set up the formula and substitute the values to find out the rank correlation coefficient. So firstly, the formula for rank correlation is 1 minus 6 times of sigma d square plus correction factor over n times of n square minus 1. So this is going to be 1 minus 6 times of sigma d square we have got as 21 plus the total correction factor we have got as 1 over n. In this case, there are 1, 2, 3, 4, 5, 6 pair of observations. So n is 6. So this is going to be 6 times 6 squared minus 1. So we can get rid of this 6 and we'll be left out with 1 minus 22 over 35. Now 22 over 35 is this 0.628. Rounding off is going to give us 0.63. And after we take it away from 1, we are going to get this as 0.37. So that is the coefficient of rank correlation. Let's move on to the next question now. So here we have, find the regression equation y on x for the following, and hence find y when x is equal to 7. And we have the table of values given to us below. Before we get started, let us see what is the regression equation of y on x. This regression equation is given by the formula y minus y bar is equal to b by x times x minus x bar. So as you can see, we will be in need of y bar, we will be in need of x bar, and also the regression coefficient b by x. And b by x is evaluated as sigma xy over n minus x bar y bar divided by sigma x square over n minus x bar square. So let's make the table. We have column x then y, we will be needing xy, we will be needing x squared. In x, we have 4, 6, 8, 10, and 12. In y, we have 7, 3, 1, 5, and 9. xy will be product of x and y. So in the first row, we will be having 4 times 7, that is going to give us 28, followed by 6 3s are 18, 8, 50, and 12 9s are 108. We will need x square, that will be square of x. So in the first entry, we will have square of 4, that is 16, followed by 36, square of 8 is 64, 100, and 144. Let us enter their totals. So in x, we have got 4 plus 6 plus 8 plus 10 plus 12, and that's 40. In y, we have got 7 plus 3 plus 1 plus 5 plus 9, that's 25. In xy, we have got 28 plus 18 plus 8 plus 50 and plus 108, that's 212. For x square, we have got 16 plus 36 plus 64 plus 100 plus 144, that's 360. Now firstly, we will evaluate x bar and y bar. So here we have x bar is going to be total of x over n, that's 40 over n is the number of pair of observations, which is 1, 2, 3, 4, 5. And so this is going to give us 8. And then we'll have y bar, which is going to be total of y over n, and that's 25 over 5, which is 5. Now next, we will go on to find out the regression coefficient dyx. So this is going to be sigma xy over n. Sigma xy is 212 over 5 minus x bar into y bar divided by sigma x square, that's 360 over n minus x bar square. So we have here 212 over 5, that is going to be 42.40 minus 8 5s is 40. In the denominator, we have got 360 over 5, that is going to be 72 minus 64. So we have got 2.40 in the numerator and we have got 8 in the denominator. And this gives us that by6 is going to be 0.3. Now once we have b by x, we can write down the regression equation. So therefore, the regression equation of y on x is y minus y bar, that is 5, is equal to v by x, which is 0.3 times x minus x bar, that is 8. Simplifying and isolating y, we are going to get 0.3x. Over here, 0.3 multiplied by 8 is going to be 2.4. And then negative 5 goes on the right, becomes positive 5. So therefore, this becomes y is equal to 0.3x plus 2.6. Take a look at the question one more time. We have been told to find y when x is equal to 7. So for that, we are going to plug in the value of x as 7 in this equation. So we get that when x is 7, y is equal to 0.3. Here you can see we have an x, so that we are going to replace by 7 plus 2.6. And this is going to be 2.1 plus 2.6, and thus we get that y is equal to 4.7 when x is equal to 7. Let us now move on to the next question. So here you see that it has been asked to find the mean values of x and y and the correlation coefficient for the following regression equations given as 5x minus 6y plus 90 equals 0 and 15x minus 8y equal to 130. So we have been asked to evaluate x bar, y bar, the correlation coefficient which is r, And there are two regression equations which have been provided to us. One is 5x minus 6y plus 90 equal to 0, and the next one is this. Now, since it has not been specified that the first equation is regression equation of x on y or of y on x, so we will be taking this as regression equation of x on y, and this we will be taking as y on x. So this is purely based on trial and error method, which you might see at the end in this case. So let's get started. First, we are going to evaluate the means. So let me start with saying that let 5x minus 6y plus 90 equal to 0 be regression equation of x on y, and 15x minus 8y equal to 130 be regression equation of y on x. To find out the means, we simply need to solve both the equations simultaneously. We'll just rewrite equation first, and that is 5x minus 6y equal to negative 90. Call it as equation number 1. Then the second equation is 15x minus 8y equal to 130. We'll call it as equation number 2. Now, it can be seen that the coefficient of x is 5 and it is 15 in equation number 2. So that could be easily equated. We'll be multiplying equation 1 by 3, and that is going to give us 15x minus 18y is equal to negative 270. Call it equation number 3. And now to this we are going to subtract equation number 2. So that is 15x minus 8y is equal to 130. So this is going to be minus. Here there is a minus sign in the second equation. This is going to be plus. Here we have plus 130. So this is going to be minus. So we can see that we get rid of 15x. And then here we have negative 18y plus 8y, that is going to give us negative 10y. And over here we'll be getting negative 400. So from here we get y is equal to negative 400 upon minus 10. I'll just give you a heads up over here. Most of the students will be ending up doing it like this. So they'll be saying that this is going to be minus 400 plus 10, because they think that this is negative 10, and when negative 10 moves on the right, it becomes addition. So it doesn't work like that. You need to see the operation between the two terms. So minus 10y means it is minus 10 multiplied by y, and since this is multiplication over here, when the negative 10 goes on the other side, it will change to division, and that is why it comes in the denominator. So once you do this minus 400 over minus 10, we will be getting y is equal to 40, and that gives us y bar is equal to 40. Now we will be substituting y as 40 in any of the equations 1, 2 or 3. Let me take equation number 1 since it has smaller numbers. So we have 5x minus 6y, since y is 40, this will be 6 into 40 is equal to negative 90. So that gives us 5x. 6 into 40 is 240 is equal to minus 90. We get 5x. Now here you can see that the two expressions which are there, one is 5x and one is 240, and there is a subtraction sign in between. So when you move minus 240 on the other side, it is going to become plus 240. So we get 5x is equal to 150, and therefore x is going to be 150 upon 5, that is going to be 30. So thus we have x bar is equal to 30. Now moving on to the calculation of regression coefficient, let us go back. We have stated that the first equation, which was this, is the regression equation of x on y. So equation number 1 is going to give us the regression coefficient bxy, while the second one is going to give us byx. So we cannot find out directly r, which the problem is demanding us. Instead, we are going to find out the regression coefficients Vxy and Vyx, and then we are going to evaluate R using both of these values. So for the first one, Vxy, what we simply need to do is we need to rewrite the equation as x is equal to ay plus b, and this coefficient a over here is going to be nothing but Vxy. And likewise for finding Vyx, we got to rewrite the second equation, which is this, as y is equal to ax plus b. This value or the coefficient a of x is going to be Vyx. So let's do that. Now we have 5x minus 6y plus 90. So we are going to isolate x. So we will be first having 5x is equal to 6y minus 90, and which gives us x is equal to 6 by 5y minus 90 by 5 is going to give us 80. So thus we have Vxy is equal to 6 over 5 with a plus sign. Now likewise, for the second equation, we have 15x minus 8y is equal to 130. From this, we are going to isolate y. So we will be having negative 8y is equal to negative 15x minus 130. And then we will be dividing throughout by negative 8. So we will have y here. And this is going to be negative 15 over negative 8 times x. And here we will have 130 with a negative sign over negative 8, which simplifies to y is equal to 15 over 8 times of x plus 130 over 8. And the coefficient of x over here is 15 by 8, which gives us that Vyx is going to be positive 15 over 8. Once we have both the regression coefficients, we are now in a position to find out R. So R is going to be given as the square root of Vxy into Vy. Now note that your Vxy is positive and so is Vyx. So R will also be positive, and therefore R becomes Vxy is 6 over 5 times 15 over 8. We could do some school calculations. So this is going to be 5 ones are, this is going to be 5 threes are. Then 6 and 8 we could get rid by 2. So this is 2 threes are, and this is 2 fours are. So R is equal to square root of 3 threes are is 9, and in the denominator we got 1 into 4, so that's 4. And we could evaluate the square root, we get this to be 3 by 2 with a plus sign. Now note that in this case, if I evaluate 3 over 2, then it is 1.5, which is more than 1. And the coefficient of correlation cannot be more than 1. Here we will state that since R equal to 3 by 2 is more than 1, so therefore R will be taking it as the reciprocal of the value which we have got. And that is going to make R as 2 over 3. So that's the last answer in bivariate linear correlation and regression. Now quickly let us move on to the next topic, that is time series and index number. So here we have using 4-yearly moving average, find the trend for the following, and further plot the given data and the moving average on the same graph. So first let us get to the first part, which is this. We got to find the trend. So for that we will be having the table vertically written. So we have here followed by the y values, and in this problem we are going to leave lines while we write down the data. So we have 1998, 1999 and so on. Then in y we got 121, 120 and likewise. We will be next adding one column and call it as 4-yearly moving totals. And for that we are going to take the first 4 years, that is 98, 99, 2000, 2001, their corresponding value, add it up and enter the sum in the middle. So we got 121 plus 120 plus 123 plus 125, that's 489. So we'll be writing that 489 here. And likewise, for the next entry, we are going to take the next four values, which are these, and write down the entry over here. So we got 120 plus 123 plus 125 plus 124, which gives us 292. And continuing so on, we will be getting the table like this. When you come over here, you will see that these 4-year totals have given us 502, and now we do not have the next 4 years, so we'll be stopping right at this end and we'll move on to the next column. The next column is going to be labeled as 4-yearly central totals, and for that we are going to add the consecutive two values in the third column and write it in the middle. So we get 489 plus 492, and that comes against the year 2000. Next, we will add 492 and 494. That's 986. We have added these 2 years and we'll be writing it in the middle. So against 2001, we will be having 986 and continue so on. We'll be getting. So we got to stop right here. And lastly, we will be having 4-yearly moving averages. So for the 4-yearly moving averages, we are going to take the totals which we have obtained in 4-yearly central totals and divide it by 8. So we'll have 981 over 8, and that is going to give us 122.63 after rounding off. Next will be 986 divided by 8. That's 123.25. 990 divided by 8. That's 123.75. 993 divided by 8. That's 124.13. 995 divided by 8. That's 124.38. And lastly, we have got 1000 divided by 8. That's going to be 125. So this is the 4-yearly moving averages which we have been asked in the question. So these are the trend values that we have been looking for. Now once we are done with that, the next part is to get the graph done. So let us plot the graph. I'll quickly change the grid lines to this. So this was the question part, just for our reference. Please remember that we got to keep the graph as basic as possible with all the details which are needed. And the graph needs to be drawn with ruler and pencil, and for that you got to ask the supervisor for a graph paper. On the x-axis, we are going to list down all the years. So here we have 98, 99, 2000, 2001, 2002, 2003, 4, 5, 6, and 7. And on the y-axis, we are going to decide the range of the y values. So the minimum value of y we have is 120, while the highest one is y equal to 126. I will be using the black color and a solid line to draw the original values, followed by another color and a dashed line to show the moving averages or the trend values. So let's start. Now for the year 1998, the y value is 121. So on the year 1998, we look out for 121 and we make a circle over here. For the 99 year, we have the value as 120. 2000, we got it 3 units up to 123. 2001, it goes 2 units up to 25. 2002, it comes down 124. 2003, it comes further down to 122. 2004, 125. 2005, 126. Then 2006, it is 125. And lastly, for the year 2007, it is again 126. Now we are going to join these consecutive dots by means of a straight line. So you got to use a ruler and a pencil for this. So here we are done, and we'll put up the legend over here. So the solid line indicates the original values. Now we got to plot the moving averages also. For that, let me use another color. Now the moving averages, the first one is 122.63, and that was for the year 2000. So we do not have a moving average for the year 98, 99 in the last 2 years, that is 2006 and 2007. So again, just remember that it is for the year 2000, the moving average, which is 122.63. So here we have the year 2000 and the moving average is 122.63. So that will be roughly between 122 and 123. So let me plot it here. Then the next one is 2001. For that it is 123.25. So that is between 23 and 24, slightly towards 23. Then next is 123.75. So that one will be towards 24. For the year 2003, it is 124.13. So that's slightly above 124. 2004, it's 124.38. So that's just below the middle value. 2005, it's 125, and that's where we stop. And again, we got to join these consecutive markings using another indicator. So here we have already used a solid line, so we could use the dashed lines or the dotted line. Let me use the dashed lines. So again, be little careful that you will be using a ruler and a pencil to do all this. And again, in the legend, we got to indicate that these dashed lines indicate the trend values or the moving average. And with this, we are done. Let's get on to the next question. So here we have the next question. We got to calculate the trend values by the method of least square for the following data. And also it has been asked to plot the given data and the straight line trend on the same graph. So we have the columns as year, sales. The sales values are nothing but Y. So we have 95, 96, 97, 98, 99. And then below that we'll be having the totals. The Y values are 70, 74, 80, 86, and 90. Let us take the Y total. So that is going to be 70 plus 74 plus 80 plus 86 plus 90. That's 400. Now coming to X. So X, we are going to assume certain values. Now before you assume X, you got to count the number of bivariate data which is provided. So in this case, we have 1, 2, 3, and 4, and 5. So in this case, since n is 5, which is an odd number, we will look out for the middlemost here. In this case, it is 97, and that we are going to assign the X value as 0. Moving up, we'll be reducing the value by 1. So this is going to be -1 and -2. And while we come down, we are going to steadily increase the value by 1. So this will be 1 followed by a 2. Then next, we are going to add columns for x, y, and x square. So again, x, y is x times y, which will be product of these two entries. So the first one will be 70 times -2, that's -140, followed by -74, 0, 86, and 180. Then next we have square of x, which will be square of entries under x column. So we have -2 square, that will be +4, 1, 0, 1, and 4. Let's total x, y, and x square. So for totaling x, y, we'll be moving like this. So we have 180 plus 86, then plus 0, which doesn't make a difference. Then we have -74 and -140. So that gives us 52. And the total of x square is 10. we leave one spare column for the trend values, which we got to calculate using the method of least squares. Now, before we get on to that, we need to calculate the coefficients A and B, which we use in the least square method. So A is given as the average of Y. So that will be sigma Y over N. Sigma Y we have got as 400. So this is going to be 400 over N, that's 5, which gives us 80. And B is evaluated as the total of xy over total of x square. The total of xy we have got as 52 and x square total is 10. So this is going to be 5.2. So the trend line equation by the method of least square is y is equal to a plus bx. Substituting the values of a and b, we get that this is going to be y is equal to 80 plus 5.2x. Now moving on to the trend values. So for the trend values, we got to substitute the values of x, which are these numbers, against every year in this equation. So for the year 95, we are going to substitute x as -2, and we will be getting, so for year 95, x is -2. This gives us that y is equal to 80 plus 5.2 times -2. So that's 80 minus 10.4, which is 69.6. So the trend value for the year 1995 is 69.6. Now, if we will observe that x increases by 1 for the year 1996, so we will be just adding one factor of 5.2 to 69.6 to get the next trend value. So to 69.6, we are going to do plus 5.2. So we get the next trend value, that's 74.8. Another plus 5.2, that will give us 80, which is the trend value for the year 97, plus 5.2, that's 85.2, and lastly plus 5.2 gives us the trend value for the year 1999, which is 90.4. And after this remains the same, that we got to plot the given data and the straight line trend on the same graph, so which I'll be skipping. So for the graph part, you can just take reference of the earlier question which we just did, this one, moving averages, and you could try getting it done. Now this question is about finding the weighted average of price relative index number for the following. This is from the topic of index numbers, and we are given a table in which we have commodities, the base price, which we are going to refer to it as P0, the current price P1, and the weights W. And we want to calculate the weighted average of price relative index number. So let's do it. So firstly, we will be modifying our table. So we have commodities, then we have got P0, P1, and W. Commodities, we have A, B, C, D, and E. The prices base 1 are 15, 20, 25 to 10. P1 is 20, 30, 45, 6, and 40, while the weights are 15, 10, 5, 1, 6. Now the formula for the weighted average of price relative index number is given as P01 is equal to sigma IW over sigma W multiplied by 100, where I is P1 divided by P0. So we will be adding one column here for I, which we evaluate as P1 over P0, followed by a column for IW. So in the first case, commodity A, we have P1 as 20 and P0 as 15. So we will be having I as 20 over 15, that's 1.33. For the next one, it is going to be 30 over 20, which will give us 1.50. For the next, we have got 45 over 25, that's 1.8. Then 6 over 2, which will be 3, and 40 over 10, which will be 4. Next, we got to do IW. So IW will be the product of entries in I with W. So for the first one, we have got 1.33 times 15, and that's 19.95. followed by 15, 9, 3, and 24. We'll be needing the total of IW, so we'll add a row for totals. So we got two total IW column and the W column. Let's start with W. So it is 15, 10, 5, 1, and 6, and that's 37. And for the IW column, we got 19.95 plus 15 plus 9 plus 3 plus 24. That's 79.5. So coming to the index number P01, it will be 70.95 over 37 multiplied by 100, and that on the calc gives us 191.76. So that's the answer. The weighted average of price relative index number for the provided data is 191.76. Moving on to the last question for today. It says to find last pairs, pastures, and Fisher's index number for the following, and we have a table of values provided to us for 4 commodities. We have the prices and quantity for a suitable base year and the prices and quantities for a current year. So again, we will be modifying our table. So we have got commodities. Then the base year price, we are going to call it as P0. Quantity will be Q0. So we got P0, Q0, and likewise for the current year, we have P1, Q1. So we have the 4 commodities here, A, B, C, and D. The prices are 9, 7, 6, 8. The quantities are 40, 10, 20, 30. The current year prices are 7, 5, 3, and 5, while the quantities are 90, 20, 40, and 30. So we will be adding 4 columns to this, which will be the products of prices and quantities. So we'll have P0, Q0, P1, Q0, then P0, Q1, and P1, Q1. So all these are going to be products of the relative prices and quantities. So for example, the first one, that is P0, Q0, will be the product of these two entries. So that's going to be 9 times 40, which is 360, followed by 70, 120, and 240. The next one is P1, Q0. So that will be the product of Q0 with P1. So the first entry will be 40 times 7, that's 280, followed by 50, 60, and 150. Next we have is P0, Q1. So it is going to be this and this. So we'll be having 9 times of 90, that's 810, followed by 140, 240, and another 240. And lastly, we have P1, Q1. So it will be the product of these two columns. So we'll be having entries 630, 100, 120, and 150. Now let's total the last 4 columns which we have added. So the total of P0, Q0 is going to be 790. The total of P1, Q0 is 540. The total of P0, Q1 is 1430, and that of P1, Q1 is 1000. Now first we got to find the last pair's index number, and that is given by IL is equal to sigma P1, Q0 over sigma P0, Q0 multiplied by 100. So we have got P1, Q0, the total is 540. So we have here 540 over P0, Q0, the total is 790 times 100. And that on calc gives us 68.35. Now next we got to calculate the purchase index number. So that's given by IP is equal to sigma P1 Q1 over sigma P0 Q1 times 100. Sigma P1 Q1 we have got as 1000, while P0 Q1 we have got it as 1430. So this is going to be 1000 over 1430 multiplied by 100. On the calc sheet it gives us 69.93. That's the purchase index number. Now the Fisher's index number is the geometric mean of last year's and purchase index number. By that we mean it is going to be the square root of IL and IP. So that is going to be square root of product of 68.35 times 69.93, and that gives us 69.13, or after rounding off we are going to get 69.14. So that is the Fisher's index number. So there you have it. We have solved some key questions from the April 2023 FYBCom Mathematical and Statistical Techniques 2 question paper covering correlation and regression as well as time series and index number. Remember to practice more problems and understand the underlying concepts. I hope this video helps for your exam preparation. Good luck for your exams. Also, for all of you FYBCom students, keep an eye out. I'll be uploading another video soon covering elementary probability theory to further boost your exam preparation. If you found this video helpful, please give it a thumbs up, share it with your friends, and subscribe for more exam-oriented content. If you have any specific questions, feel free to ask in the comments below. Thanks for watching and happy learning.